All right. This is an old sheet, but it's got some cool problems on it. And answers are posted, but I'll talk through some of them that a little bit more challenging. I think number one's pretty straightforward. In the second one, this 72 degrees is this arc here. Okay. So that should be pretty straightforward as well. C, no big deal. Okay, moving down here. Pretty straightforward. It's not until we get to a little further down that it gets more interesting. 36 degrees. These are like warm-up, feel-good problems here. This would be 36 degrees as well. So F, on number 5, F is talking about this obtuse looking angle here. Obviously, if this is 158, this tangent chord angle has to be half that. So that would be 79, which makes angle F101. 114 is, now, I will tell you on this sheet, folks, you're going to have to assume tangencies. Doesn't always say. So this, that's a tangent, that's a tangent. So just go ahead and assume that. Just like we did there. It really technically should specify. Same thing here. It really should have specified that was a tangent, but there's no instructions here really. It's just you're going to make that assumption. G should be pretty straightforward. That's a tangent angle and a minor arc. They have to add up to 180. Okay, down here it starts to get a little bit better anyway. H is just half this difference. So that would be 30 degrees. I is an inscribed angle. Just add these arcs together, cut it in half, 97. Now the next one here, this can get a little bit more interesting. By the way, this is the J, got cut off. And it's talking about this angle right here. This one's tough sometimes, so you might want to, you might want to pause and give it a try. I'm going to, reveal it here in a second. I will give you a hint in a moment if you're looking at that. Remember that here's the hint. This segment here is a diameter. That's hugely important. And you got to make sure you pay attention to those tick marks. All right. So here comes the reveal. Because this is a diameter, that's a semicircle of 180. That means that's a right angle down there. And because this with the tick marks is twice that, it's a 30, 60, 90 triangle. So J is 30. Okay. Over here, the one on the right, this one causes difficulty sometimes too. There's some different ways of approaching it, but what I would say is, again, you might want to pause for a moment, give it some, I don't really have a hint. I mean, I'd work with that 90 first. It would be the hint. Hey, if this is 90, that means that this is 180, this arc. That means that is 180. And angle M is intercepting that. Angle M is an inscribed angle, so angle M is 90 degrees as well. Okay? So now once you got angle M, of course, you can just add all these angles up and subtract from 360 to get N of 102. I forgot to write in K here, but K should have been pretty straightforward. If that was 60, of course, K is 120. So those two problems there, 8 and 9, they cause some difficulty sometimes. All right, let's take a look here. So Q is this little angle down here. Sorry, some of these diagrams aren't perfect, but we'll just do the best we can. So, what can we do here? This is 44. So that means that's 44. So angle Q is an inscribed angle. It's got to be half, 22. Let's see, what can we do here? Remember, this thing's going through the center, so that's a diameter. So if that's 44, this is 136. And this angle on the outside is half of this difference. So 136 minus 44, what's that going to be? 92. P is going to be half that. Okay, these definitely get a little harder here for sure. This one maybe not so much. S is just an inscribed angle, so S it's got to be half that 48. Let's see, now R, sometimes it's hard to, R is this angle up here. So let's see if we can figure that thing out, right? Okay, so if this is 48, that arc, this angle here is also intercepting that arc and it's inscribed, so that's 24. And now we have a right triangle with 90, 24, so that R has to be 66. Okay, now let's see what we got here. So in this next one, it's kind of a little bit confusing in this diagram maybe. V is this entire angle. Okay. 82 is that central angle. 32 is this arc here. Okay. So let's see what we can do here. Remember, something I haven't mentioned here recently, this is hugely important though. This 82 is a central angle. We have an isosceles triangle here made up of two radii. So if we know the vertex angle is 82, this base angle has to be 49. Of course, that one over there is 49 as well. But that will allow us to figure out this angle T here, because it's supplementary to the 49, so that's 131. And let's see here, if this is 32, this would have to be what? Half that, 16. Okay. So if we have, now we can look at this big obtuse triangle. If that's 131 and that's 16, together that's 147. So angle U has to be 33 degrees. And angle V, let's see, what can we do there with angle V? Oh, well, angle, just thinking a little bit here. So if this is 82, this has to be 82. And remember, we got U to be 33. That's 30. U is half the difference of this minus the 32. So U was what? 33, so 6. So we have this arc here, arc minus the 32 over 2 equals u, which is 33. So if that was times 2, I'm just doing a little solving here. So you get 98 to be, oh, I could have just gotten that from the 49. Sorry, that was way longer. 49 is inscribed. That gives you that 98. And then I can add up these three, 98, 82, and 32. Subtract that from 360. Something isn't quite right here. 32, 98. Oh, no, this is okay. And we would get 148. So angle V would have to be half that. And you get 74. Okay. Just verifying a couple things. So if that's 74, this is 82, that would be 41 plus 74 plus 16 plus 33. Something isn't right. 41. Oh, I see what I did. Let's fix this. So when I did angle V, I took half of 148, but remember, I should have had the 32. This is actually a diameter. Angle V is just 90 degrees. And that should make more sense. Okay, that's 90 degrees. We could have gotten that one right away. I made that one way harder than it was. Way harder than it was. All right, let's take a look at these last three. Let's see what we can get here. I'm just going to fill in some blanks. I know this arc is 62. I know this arc is 80. And I know that this is a diameter. Okay. So that means this arc here has to be, even though it doesn't look like it, has to be 100. So angle X is inscribed and intercepting that 100 degrees, so that's got to be 50. Okay. Now this W, I know it's hard to tell, that's the angle out here. Okay. And this 100 was from there to there. Let's go ahead and fill in the rest of these blanks. If that's 62, this has to be 118. And let's see if we can get the rest of this thing here. If X is 50, that's 118. That means this is 118 because of the central angle. So together that's 168. So looking at this triangle, that's got to be 12 degrees. Okay. Almost there. Now here we got an isosceles triangle. 58's in the corner there. So that means Y has to be 58 as well. Makes this 116. Okay. Because of the inscribed angle. Let's see, what do we have to find? We have to find Z. Actually, what we can do is get this to be 64, which means this is, well, we really knew that anyway. This is 64 because of the central angle. That's 64. So this angle on the outside, we can add these three arcs together, which is 244. And remember that subtract that from 360, you get this arc to be 116. And this is a tangent angle. And if that's 116, Z has to be 64 because a tangent angle and its minor arc add to 180. All right. Again, assuming tangencies. Sorry about some of these lousy diagrams. Now, so this is a tangent right there. So that's a right angle. That's a right angle. Now, there's a chord right there. It's really close to the circle. It's kind of hard to see. These are Greek letters here, alpha and beta. And, we should be able to figure this out pretty quickly. Because watch, this is 24. It's an inscribed angle, so that must be 48. That's a central angle. This must be 48. We have a right triangle. So if that's 48, alpha down there has to be 42. Okay. And remember, these two triangles that I'm going to bold in blue, these two right triangles, they're going to be congruent, right? Because you know that these tangent segments are congruent. You got right angles, you got radii, you got reflexive, you can do SSS. There's a bunch of different ways to get these triangles congruent. So if this is 48, so is that. Makes this arc 48. And beta is an inscribed angle intercepting this 48 plus 48, intercepting this 96. So half of 96 is 48. There's some real cool problems there. Some of them are easy. The big ones in the beginning are warm-up problems, but there's some trickier ones later on. And hopefully that helped a little bit if you have questions on these. But that's going to wrap up this section, 11.4. Have an assignment, and we'll get into 11.5 in the next one. Be good.